morning friends, I welcome you all for another lecture on the course Microprocessors and Microcontrollers. Up to now we are discussing about a 80386 processor. Before that we discussed some 8086 processor. After finishing of this, I was shifted to microcontrollers 805. Before discussing different concepts in 8051 microcontroller, first I would like to compare a microprocessor with microcontroller. So that's why please listen carefully this particular video. If you listen carefully this, you can easily understand the basic difference between a microprocessor and a microcontroller. Right. Here, my first point is a microprocessor contains ALU, GPRs, PC, SP, control and timing circuit along with interrupt circuit. So, your microprocessor consists of these different blocks. It has an arithmetical logical unit. It has a group of registers. GPRs means general purpose registers. And next PC means program counter. SP means a stack pointer. These are the group of registers present on our processor. Along with that, it has control and timing circuit. And some processors have interrupt circuits also present. But coming to the controller, it contains a microprocessor. It has inbuilt read-only memory as well as a random access memory, and it has I/O ports for connection of I/O devices, and it has a timer and counter circuits, etc. That means your microcontroller is a superset to microprocessor. Why? Because this microprocessor is a part of your microcontroller. So that's why this microcontroller contains a microprocessor, inbuilt read-only memory, random access memory, and it has an I/O ports for connection of our external devices or an I/O devices, and it has onboard timer/counter circuits. So from the first point itself, we have an idea that these microcontrollers are far greater than or more than more than our microprocessor. And coming to next one, in case of microprocessor, it has many instructions to move data between memory and CPU. That means to do data transaction between our processor and the memory, the processor instruction set have more number of instructions. But the case of controller is completely different, friends. That's why if you see this point, it has a few instructions. That means it has a less number of instructions to do a data transfer between memory and CPU. But your processor have more number of instructions for data transferring between a processor, that is nothing but CPU and memory. And coming to next, the access time for memory and I/O devices are more in case of processor based systems. The reason for this is, for a microprocessor we didn't found memory elements on chip, these are off chip, and we didn't found I/O ports on chip, and these are off chip. With the help of I/O ports only, we are connecting I/O devices to our processor, so that whenever your processor wants to communicating with the memory or it communicating with our I/O devices, it takes much more time because the memories are not available on a processor itself and your I/O ports also not available on processor itself. So that the accessing time is more. But coming to the controller case, it has a less access time for inbuilt memory and I/O devices because your microcontroller has inbuilt a random access memory as well as a read-only memory. So once your memories are inbuilt, It takes less time to communicating with memory locations. And similarly, it takes less time to communicating with I/O devices, because for the connection of these I/O devices, your controller has I/O ports on board, so that the accessing time is less. And coming to next, microprocessor based system requires more hardware. That means if you want to make a system, in a system your central processing unit is a microprocessor, then you need much more hardware to making up that system itself. That means you need a memory elements, you need an I/O ports, we need a different circuits for making up your application. But coming to the controller case, it's completely different. Coming to microcontroller based systems require less hardware. The reason for this is, for microcontroller you may found onboard memory elements as well as onboard I/O ports. So that automatically the hardware required for making of microcontroller based system is less compared to microprocessor. So coming to up to these points says your performance of microcontroller is superior than microprocessor. But coming to the next point, it is somewhat reverse. Microprocessor based system is more flexible in design point of view. Microcontroller based system is more flexible. That means in microprocessor based systems, I select a microprocessor based on my application. I select the memory elements based on my application. I select I/O ports based on my application. So I have more flexible. But coming to the controller case, microcontroller based systems is less flexible in design point of view, because microcontroller have a fixed memory elements present on board itself, as well as it has a fixed I/O ports, so that the design flexibility is less. So from this point we can say that the performance of microprocessor is superior than microcontroller. And coming to last but one, less number of pins are multifunction. That means out of some good number of signals of a processor, only few signals have a multifunction. That means they can do more than one function. But coming to the microcontroller, you may found more number of multifunction signals or multifunction pins. That means out of some n number of signals of your microcontroller, more number of signals have multiple functions. That means the signals can do more than one function. That is this. And coming to the last simple point is what a microprocessor. I can say in a simple statement, a single board CPU is called a microprocessor, and a single board computer is called a microcontroller. Because if you go for a single board CPU, is called a microprocessor, because a CPU contains all these blocks. ALU it has, GP has, PC, SP, control and timing circuits, as well as interrupt circuits. All these are present on CPU. But if you are coming to the computer system, you may identify that a processor, which is act as a CPU, and it has a memory elements, both the read-only memory as well as random access memory, and it has an I/O ports for connection of I/O devices. So that here I can say that microcontroller is a single board computer. It's called a microcontroller. And last one is coming to examples for a microprocessor. You can go and write 8085, 8086, 80286, 80286, 80386, 80486, like this. We can write so many examples. Let you can assume that was an 8 point. So examples for microprocessors are like this. And similarly, examples for microcontroller: 8031, 8051, 8052, PIC 16C, 61, 16C, 71, etc. These are the different examples for microcontrollers. I hope you understand, friends, the comparison between a microprocessor and microcontroller. Thank you for patient listening. We'll meet on next class.